Now that we've downloaded R, let's begin using it. So, one example, classic example in statistics, is to look at the coin toss. And so in this case, with R, we could create a variable in which we could enter values that would be similar to a coin toss. And for this, we will use the concatenate function, C, and let's enter simple values of 1 and 2 representing the faces of a coin. If we enter then XX, what we find is that using this concatenate function, we've created an array XX in which 1 and 2 are the values. Now to actually simulate the coin toss, we could sample this function. So sample, and we sample the object XX, and we tell it how many times we want to sample this object. We can repeat this command by, instead of typing it again, we could push the up arrow and repeat this, and eventually then we will have sampled both values. To make this more realistic, we could actually create a variable coin, in this case, in which we concatenate actual characters, which are denoted with these quotation. And so now we can sample or randomly sample coin, and let's say we want to randomly sample it 2 times. And in this case then we've gotten, in both coin flips, we've gotten 1 of each face. We can repeat this command a number of times, and the curious thing is that we continually get both faces that come up. We can learn more about this function sample using the question mark sample, and this then will pull up your server or web browser, and you can learn more information on any of these commands by using the question mark. But what we find then is that the default for sample is that it does not replace the values in which it has sampled within the array. And so in this case then we will always get 1 of each face. To get truly independent flips of the coin then, what we want then is to set the replace function to true. And now we can get heads heads, we can get heads tails, and you can imagine then that by sampling any number of times we could reproduce or estimate the probability of getting heads versus tails within this variable. And so we could sample then this coin, let's say 100 times, and we want these coin flips to be truly random, and so we get this this output. This output is a little unwieldy, so let's enter the output into a variable. So coin toss is going equal to sample coin 100. And for this, instead of simply displaying the results, let's tabulate the results on our coin toss. And so we can then create a table coin, and we find that in this instance then, in this set of 100, we had about a 40 to 60 ratio of heads to tails, which is a little off from what we would expect. We could up the ante a little bit and perhaps replace the coin toss not 100 times, but maybe 1,000 times. And so in this instance, let's now tabulate the results. And you can see in this case it's much closer to the results that we would expect. One of the great features of R is actually its graphical capabilities. So instead of looking at just numbers in a table, we could also plot out our results of our coin toss. And so one thing we could do then is look at it as a bar plot. And we want to plot not the coin toss itself, but the tabulation of the results of the coin toss. And so we see that we have fairly nondescript bar plot of heads versus tails. We could have something a little more exciting, maybe a pie plot or pie chart. And in which we can see that it's roughly an equal distribution of heads versus tails, or H versus T. We could also change the labels. So if we look at, for example, the labels in which we see that the labels of our table are H and T. We can change the names on the table, the bar plot, or the pie chart. One way of doing this is to create first we'd want to put the table of the coin toss into another variable. And so now we have the names. We can retrieve the names of our table, right? And we can change the names by using our concatenation program or function and changing it then to heads and tails. And so now if we look at the names of our coin toss, we see that it's heads and tails. We can then create a table, or sorry, a bar plot of our table of coin toss, or we could also create the pie. Another thing that you may be interested in doing is actually saving these graphical results into some form in which you could turn in. And so in this case then, you could do this through menu. You can go to the Save As, and there are different options. So for example, if we wanted to create a PDF, we just hit PDF. We could download this into, we could save this onto our hard drive in some way. And then we can pull this up. And you can see we've effectively save then our graph. And this could be in any format that you desire to put into your report or what have you. Now let's expand on our example and move from a coin to a die or dice. And so in this case then, let's take our dice and we can use the concatenation function and expand on our XX variable, which already contains the numbers 1 and 2. So if we concatenate XX with 3 through 6, then we will have created our virtual dice, or six-sided dice. Again, we can sample to calculate to get a rough estimate of probability in which we would roll any number or any face 1 through 6. And so in this case we'll create dice toss, which is equal to the sample of variable 1000, and we want to replace, because each of those 1000 tosses will be an independent sampling. We can then look at or tabulate our results, and we find that it's a fairly even distribution across the 6 faces. It's a little difficult to see within the numbers, they're all fairly close, but we could, similarly as before, we could look at a bar plot of our table. It's fairly evenly distributed. And we could also look at a pie graph, for example. Again, fairly evenly distributed.